Good day everyone. Today we will solve the number 16 problem from the basic principles of electricity. A certain wire has a resistance R. The resistance of another wire identical with the first except for having twice its diameter is. So we will use the formula resistance is equal to the resistivity multiplied by the length times area. We will assume that the length of the two wires in both conditions to be constant, and with the length constant, the resistance of the wire varies inversely as the square of the diameter. So since the length are not given, we will consider it as constant. And we will manipulate the formula resistance is equal to the resistivity all over length all over area by changing the area, which is also equivalent to pi over 4d squared. And only left is r is equal to k multiplied by l all over d squared. Since length will be considered as constant, the resistance will be equal to k all over d squared, which k is the proportionality constant. And then we will jot down the given, which is the second diameter is twice the first diameter, and the resistance 1 and resistance 2 are equal. And then we will input the given to the formula. R2 all over R1 is equal to D1 all over D2 square, wherein resistance 1 and resistance 2 are the same. And to find the second resistance, we will multiply both sides by R1, and we will get R2 is equal to R1 multiplied by D1 all over D2 squared. And then we will change the value of D2 in terms of D1, which is D2 is equal to 2D1. And R2 is equal to R multiplied by D1 all over 2D1 squared. And we will cancel D1 and 2 squared, and 1 half squared is equal to 1/4 multiplied by R is equal to R all over 4. And the resistance of the second wire will be R all over 4 ohms. A given wire has a resistance of 17.5 ohms. If its length is 560 meter, how much length must be cut off from the wire to reduce its resistance to 12.5 ohms? What is the size in square millimeter is the cable of 250 MCM size. A 500 MCM ACSR cable has 37 strands. Determine the diameter in mils of each strand. The only given in this problem is the 500 MCM and the number of strand, which is 37. First, we need to convert the MCM into cm, which be equivalent to 500 times 10 raised to 3 cm, since 1 MCM is equivalent to 10 raised to 3 cm, and we will get 500,000 cm. And to get the cm per each strand, we only need to divide it by its number of strand, which is 37. 500,000 divided by 37 will equivalent to 13,513.51 cm. And to get its diameter, we only need to square root the cm, which be square root of 13,513.51. And we will get the final answer 116.25 mils. A copper transmission line is to be replaced by one of aluminum having the same total resistance. If the cross-sectional area of the copper wire is 500 MCM, what would be the cross-sectional area of the new aluminum wire? For aluminum, we will use the subscript A, and the resistance is equivalent to resistivity multiplied by the length all over the cross-sectional area, where the resistivity of aluminum is equivalent to 17 ohms cm per feet. For copper, we will use the subscript C, and its resistance is equivalent to resistivity multiplied by length all over cross-sectional area, and the resistivity of copper is equivalent to 10.37 ohm cm per feet. Since the total resistance of the aluminum wire and the copper wire in this problem is equal, we will equate those equations. And we will come up with the formula resistivity multiplied by length all over cross-sectional area of aluminum is equivalent to the resistivity multiplied by length all over cross-sectional area of copper. And to find the cross-sectional area of aluminum, we will use the formula cross-sectional area of copper multiplied by the resistivity of aluminum all over the resistivity of copper. We will get this formula by manipulating the formula of when we equate the resistance of aluminum and resistance of copper. And we will get the value 500 multiplied by 17 all over 10.37, and it will be equivalent to 819.672 cm or simply 820 cm.